Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today we are going to discuss about the ground improvement techniques OBE. OBE is nothing but outcome-based education. So, according to the outcome-based education, how we are understanding these ground improvement techniques? So, what are the course outcomes as per the program outcomes? How we define those course outcomes? How we are mapping with them to the POs, those kind of things we will observe in this particular class. So in this lecture, the first thing what we understand, this is the pre-requisition course, that is the geotechnical engineering. So in our class, throughout in our lectures, we talk about the soil properties or various technologies. In this soil properties, different number of properties are there in each kind of soil. So we are doing the categorizations, classifications according to the property. So like by different types of, by the fine aggregate, by the size, and also so like that we are understand because of the geotechnical engineering. So in these soils, this is in the overall view of this soil. The soils at construction sites are not always suitable for supporting physical infrastructure, such as buildings, bridges, highways, tunnels, and dams. Under all these conditions, the soil needs to be treated using ground improvement techniques. Similarly, specific types of soil improvement techniques are required in the case of expansive soils, collapsible soils, and in other scenarios are also there in the case of earthquake regions. So, this course addresses various ground improvement techniques along with their principles, design issues, and construction procedures. So this is the course overall view. So in this course objectives, the student will try to learn the importance and fundamentals of ground improvement techniques for measuring field parameters by using traditional and modern methods involved in civil construction. Move on to the objective 2, the mechanical methods are suitable equipment to proliferate the ground for making soil withstand all the loads acting on it. The physical and chemical and hydraulic methods and its application for strengthening of the soil is another kind of course objective. In this, the applications of modern methods in civil construction, alteration works, shotcreting, soil reinforcement, soil laying, bolting involved in this inclusion and confinement process. And these are the course objectives which we are going to learn in our ground improvement techniques. The most important thing, those are the course outcomes. Once after completion of successful completion of this course, the student should be able to understand these course outcomes. Those are, in this, the one is recall the problems associated with the existing ground condition to propose a suitable method for ground improvement. So based on the suitable method based on the condition, we are suggested which method is suitable for the particular ground improvement, and also explain what are the various methods of mechanicals to increase the bearing capacity of the soil. So what are the techniques involved for getting the better increased bearing soil capacity under mechanical modification. In this course outcome 3, existing ground condition of a design of the dewatering system control the seepage of groundwater. In course outcome 4, the select appropriate geosynthetics to increase the bearing capacity of the subgrade soil. Identify the suitable grouting technique based on the in situ evidences to prevent the foundation settlements. Choose the appropriate soil reinforcement techniques to increase the stability of soils. These are the course outcomes we will, after completion of the course, we will understand. In these 5 modules in our particular course, we divided into the 5 modules. That the one is introduction to ground modification, mechanical modification, hydraulic modification, physical and chemical modification, modification by inclusions and confinement. In this introduction to ground modifications, we understand what are the why need of these ground improvement techniques, what are the various objectives involved in this, how we are identify the soil types, what are the laboratory tests involved in this characterizing problematic soils. So how we are going to categorize it like mechanical, hydraulic, physical, chemical, electrical, thermal methods and their applications. So in this, because of this, we have to prerequisite of this particular subject is geotechnical engineering. There we are understand the soil types, what are the laboratory tests are there. So we will know basic things about these things in our prerequisition subject. So here in this we understand identification of the what are the various soil types, laboratory tests where we are going to conduct, what are the various methods involved in this as per classification. In this mechanical modification, what kind of techniques we are using, what is the principle involved in it, where we are going to use these kind of techniques, what are the properties are going to modify because of these techniques, and what type of construction work these mechanical modifications are suitable on which type of soil based on the type of the soil. In this, deep compaction techniques, blasting, vibro compaction, dynamic tamping and compaction piles are there. Move on to the hydraulic modification. In this, objective and techniques, what kind of techniques are involved for these hydraulic modifications as per the ground improvement point of view. So in this, traditional dewatering methods and their choices. So in these, different kinds of dewatering techniques are available according to the situation, according to the water table level, that groundwater movement. So according to that we are choosing in that dewatering method. And these dewatering, how the systems, how they are going to design, which kind of principle is involved in this, these are the parameters which are involved in this particular thing. And also after, in some of the situations, the dewatering techniques, the traditional dewatering techniques may not effective in that particular scenario. We may choose these electroosmosis and electrokinetic dewatering systems where we are considering these as the advanced methods, improved methods like that. So that scenario we will understand in this hydraulic modification. In physical and chemical modification, we are for getting the physical change of the, in physical point of view, the changing of these modification, we are going to use some kind of admixtures. So what kind of different admixtures we are using, what are the techniques involved for using those kind of admixtures, so that modifications happen may admixtures and other different techniques. Those are shotcreting and gunting technology, modification at depth by grouting, crack grouting, compaction grouting, jet grouting, thermal modification and ground freezing. These are all comes under in this. In this, what kind of chemicals are effective for getting the desired soil properties, how the properties are effective in this particular, we are understanding all these parameters in this particular module. Now move on to our last module. We are understanding the soil reinforcement, any inclusions and confinement under which type of modification we are going to done in this soil reinforcement with strip and grid reinforcement soil. What are the various on-site ground reinforcement and ground anchors, this rock bolting and soil nailing. So how where we are using those kind of modification techniques for getting the desired properties of the soil. So which type of projects are demand using these kind of technical modifications we will see in this module. So here, so the OB, outcome based education, in this it comes under in these 6 steps. That one is, the first one is remember. We are going to remember the things. And next one is understand. For understand, in this we are going to understand the what are the based on the terminology, we are going to understand the particular terminology as per the subject, and where we are going, once we understand the things, now we are going to apply, where we are going to apply those kind of what we understand the things, or whether it is maybe technique, whether it is maybe the principle. So according to that, we are where we are applying, and after that we are going to analyze those, where once we apply these things, next we are going to analyze, and the next step is the we are going to evaluate, and we are going to create the things. So like this we are going to understand this OBE. So remember, understand, apply, analyze, evaluate and create. In this particular module, these 5 comes under understand, remember, understand and apply. So this course knowledge competency level is till apply. In this, program outcomes are involved. Those are engineering knowledge, PO1 that is engineering knowledge, PO2 that is equal to problem analysis, PO3 design and development of solutions, PO4 conduct investigation of complex problems, PO5 modern tool uses, PO6 the engineer and the society, PO7 environmental and sustainability, PO8 ethics, PO9 individual and teamwork, PO10 communication, PO11 project management and finance, PO12 is life learning. These are the 12 program outcomes. They are defined by the NBA. So as per this, where PO1 is nothing but where we apply the knowledge of mathematics, science and engineering fundamentals and an engineering specialization to the solution of complex engineering problems. Coming to the problem analysis, we are going to identify, formulate, review, research literature and analyze complex engineering problems, researching sustained conclusions using first principles of mathematics, natural sciences and engineering sciences. In PO3, design and development solutions are considered in this. So we are going to design solutions for complex engineering problems and design system components or process that meet the specified needs with appropriate considerations for the public health and safety and cultural, societal and environmental considerations. And conduct investigations of complex problems, use research-based knowledge and research methods including design of parameter, analysis and interpretation of data and synthesis of the information to provide valid conclusions. In modern tool usage, create, select and apply appropriate techniques and resources and modern engineering and IT tools including prediction and modeling to the complex engineering activities with an understanding of the limitations. In PO6, the engineer and society apply reasoning enforced by the contextual knowledge to assess social health, safety, legal and cultural issues and the consequent responsibilities relevant to the professional engineering practice. In environmental and sustainability comes under PO7. It's understand the impact of the professional engineering solutions in societal and environmental context and demonstrate the knowledge of and need for the sustainable development. Coming to the PO8, ethics, apply ethical principles and commit to professional ethics and responsibilities and norms of the engineering practice. In PO9, individual and teamwork, function effectively as an individual and as a member or leader in diverse teams and in multidisciplinary settings. In communication, as a part of PO10, program outcome 10, communicate effectively on complex engineering activities with the engineering community and with society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations and give and receive clear instructions. In PO11, project management and finance, so demonstrate knowledge and understand of the engineering and management principles and apply these to one's own work as a member and leader in a team to manage projects and in a multidisciplinary environments. In PO12, lifelong learning, recognize the need for and having the preparation and ability to engage in independent and lifelong learning in the broad set context of the technological change. These are the program outcomes. So according to the program outcomes, we are assessed the particular course. Here, PO1, PO2 and PO4 are there. So in this engineering knowledge, problem analysis, conduct investigation of complex problems we are going to understand. The strength is we are considering 3 parts, that is low level means 1, medium level means 2, high is 3. So here for PO1 that is 2, PO2 3, PO4 3. So these assessed by using the CIE, SE, AAT tools. And this 4 is in using the AAT. In PSO1, it is the specific outcomes relevant to the program. So in civil engineering program, that PSO1 is design and supervise substructures and superstructures for residential and public buildings. So industrial structures, irrigation structures, powerhouses, highways, railways, docks and harbors. So for this PSO, this course is strength is in 3, it's in high level. PSO2 is focus on improving performance of structures with reference to safety, serviceability and sustainability green building technology. It comes under 2. So these assessed in the both CIE, SE, AAT. So the CIE is continual internal examinations, SE is the semester end examinations, AAT is the tool which we use for assessing the part of the CIE. In this mapping of each CO with PO and PSO, this CO1 is mapped, all CO1 to CO6 is mapped with PO1 and PO2. Now coming to the PO4, that CO2 and CO5 are mapped with this PO4 because it's partially and all it is going to understand the investigation complex issues only. So for that purpose, we are considered like this. In PSO1, the CO1 is mapped with the PSO1. CO2 is mapped with PSO2, CO3 is mapped with PSO1, CO5 is mapped with PSO2. So like that we are mapping our each CO with POs and PSOs. In this, the justification we are going to understand. So here we have number of key competencies for this matched is 2. For PO1 and PO2 is the key competencies are 2. For PSO1 it is also 2. According to that, we are going to analyze for all the 6 POs, 6 COs with our POs and PSOs. Now, total out of key competencies for CSO and CSO mapping is like this. So, CO1 to CO6, that PO1, PO2 is fully mapped with all the COs. Now, this is CO2 and CO5 is mapped with how much strength it is there. So, percentage of key competencies we are calculated as per the percentage as per the number of key competencies which are going to map in that particular thing. Now we are understanding the articulation matrix. So according to that we are getting the average values for the COPO mapping, and these are the assessment tools we are choose for understanding this CIE, SE examinations, and also the we are asking the mini projects for this asserting this in this particular thing. So these are the assessment methods we are going to follow. We are understanding the COs and COs and PO mapping and PSOs mapping. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.